Hello and welcome back my YouTube channel Engineering and Construction Point. Dear engineers friend, today this video will help you once you will watch. In advance I'm telling you this video is going to be long little bit because of in this video lecture you are going to learn how to find out the column main bar quantity and ties, how to find out the quantity of column concrete, and how to find out the shuttering quantity. And number 4 point is what is hooks and hooks size, hooks angle, and lap zone for the column. Right, so let's start. This is the column plan. Let's assume this is C1 column. This is C1 column and the size of this column is 300 by 300, and here is our main bar of the column is 4 number 16 dia. Okay, and the another bar in alternate or in middle is 4 number 12 dia. Just you have to keep in mind this is EQ. EQ is equal distance. Equal distance. Okay, so between main corner column you have to equally provide the 12 dia bar on equal distance. This is also 4 numbers, right? And the main ties is 8 external ties, and internal ties bar to bar is also 8 Okay, this is internal ties, this ties is internal, this is external. Okay, here you can mention like E to understand easily. Here you can write I is internal. Okay, this is called hooks. This is here mentioned. This is called hooks. Okay, my friends, this is hooks, and the angle of this hook from the main ties shall be 135 degree. Turn at 135 degree. This should be at 135 degree. And this is hooks, this is hooks, this is hooks, this is also hooks. This is called internal ties, this is called external ties. Okay, this gap is what? This gap is concrete cover, that is 40 Okay, this gap is called concrete cover and it should be 40 And why we provide the concrete cover? To save from the environmental effect, to save from the rust to the columns. That's why this concrete cover is very important. And why we put the ties? Ties is to share the force. When the tension comes on main column bar, this ties work is to distribute the tension to all columns main bar. That's why ties is necessary. And the another main job is to keep their original position of main bars, to keep the main bar on their original position. Okay, so this is the column plan at C1 and reinforcement detail. Now this is the section. This is the section of the column. This is as mentioned here 8 dia as the rate of center to center 100 Okay, C/C as we have earlier discussed, this is called center to center. Center to center. Okay, this is called center to center. So this is also 100 and at the same place this internal ties shall be also at 100 It's here also mentioned. Okay, 8 bar internal ties as the rate of center to center 100 bar. to bar. Okay, to ties the bar. Okay, this main column bar is 16 mm and internal bars which is distributing equally from 16 mm dia corner bar to another corner bar is 12 mm dia. Okay, now this is the section. The section is also here concrete cover. This is 40 mm. This is the ties and the distance of ties is 100 mm. This is the section. Now we are talking about the hooks. Hooks shall be everywhere and at 135 degree, and hooks dimension should not be less than 10D. Okay. Now talking about the lap zone. Let's assume floor to floor height as mentioned here. Floor to floor height is 300,000 mm or 3 meter. Okay, this is one slab. Let's assume ground floor we have completed, and this is the ground floor slab, and now column towards going for first floor. Okay, this is, suppose, let's assume first floor, and this is ground floor. Okay, so what will happen in this? Here you have to keep, first of all, the main bar, same column main bar shall be a gap of 40 mm from for concrete cover, and this reinforcement will get merged with RCC slab at least 300 mm. 300 mm. Okay, this is 300 mm going to merge with concrete slab. Okay, at first floor slab or ground floor slab, both side there is mentioned. It's, if this is ground floor then it will go 300 mm, this is first floor, it will go 300 mm. Okay, now this is the ties. Okay, now this area is called tension zone. This area is called tension zone as mentioned here. Okay, this is tension zone. Suddenly force, tensile force and compressive force comes here. So we should not give the lap below the slab both side. Lap shall be in the middle of the column height, or it should be alternate also. As I have mentioned here, one lap is here and one lap is here. This is alternate. And how much? For 16 mm dia bar we have to keep 50D, and for 12 mm dia bar also we have to keep 12D. Okay, then it means 50D, D is the dia of the bar, then here should be 16 into 50, 16 5s are 80, it should be 800 long lap and should be alternate. As per design, as per civil standard, civil engineering standard, lap shall be alternate. Okay, and it should not be in tension zone. This is also a tension zone because of slab. Here is slab and column is going on, right? Column main bar is going upward direction. It should be also in middle. It should be also from top also in middle and bottom also in middle and alternate. Okay, so this is okay now. Now friends, just keep in mind, these are the very important point to understand, to carry on at site. Whenever you are working at site, these things you have to keep in memorize. It should not be available everywhere in drawings, but you have to keep in mind how to execute the civil activities. Number one is column main bar lap should not be less than 50D. Column main bar lap should not be less than 50D, as I have spoken earlier also. This is the lap and it should not be less than 50D. It should be 50D. Another point is column lap should be alternate, as here I have shown one lap is here and one lap is here and another lap is here. Okay, right? This is also lap and this is also lap. Okay, and it is alternate. Now point number 3. Point number 3 is hook's length should be 10D of given ties. Suppose 8 mm dia bar ties you have to use, then it should be 10D. 10 into D of the die of the bar, 10 into 8, it should be 80 mm minimum. And the hooks should be turned at 135 degree from the external bar. Okay, external bar, external ties. And the fifth point is main bar lap should be in middle, not in tension zone. Not in tension zone. Not in tension zone. Okay, so this is very important to understand. So this is, hope this will work in your daily civil activities, especially when you are going to work RCC slab or RCC column work. Okay, now we are going to see the another thing, how to calculate the reinforcement. Okay, now let's start to calculate the reinforcement. Number 1, calculation of a steel bar and ties. Okay, first we are doing calculation of a steel bar and ties. As mentioned, floor to floor height is 3 meter or 3000 mm. Lap should be 50D. This is mentioned. This, let's assume it's mentioned in drawing, and this is mentioned in drawing. And 4 number 16 dia and 4 number 12 dia. This is already mentioned here. For C1 column, as I have shown you in C1 column, this is here C1 column. This is the C1 column. Okay, and here is mentioned 4 number 16 mm dia and 4 number 12 mm dia, right? And ties is 100 mm center to center. Okay, so now how to calculate the steel reinforcement for this column. Okay, main bar shall be merged with 300 mm in slab reinforcement. This is also mentioned. Now main bar 16 mm dia. How to calculate? This is 300 is what? 300 is getting merged with slab. 300 is this. 3000 is height. 800 is lap for 16 mm and 300 for top slab. Okay, total you have got 4.4 meter. Okay, now 4 number bar is mentioned, 16 dia, 4.4 into 4, it will become 17.6 running meter, right? This is, you have got 4 number bar. Same should be for 12 mm because of going on together. All bar is going on together. Now how to calculate? Calculation is 16, as we know dia square divided 162 to find the per meter length or per meter weight for the reinforcement. This is 16 into 16 into 17.6. Okay, divided by 162. How much you have got? 27.812 kgs. Let's say add wastage also 30 kgs. 30 kgs you required for 16 mm dia, and same should be, calculation would be only here 12 mm and 12 mm, and then it will come here also. Like this is, I have calculated for 16 mm. You can calculate for 12 mm also. Okay, because of length is same, calculation will be also same. Only a place of dia, a place of 16 into 16, it should be 12 into 12. And the running meter will be 17.6, same, divided by 162, you will get the weight of this 12 mm dia bar also. Now talking about the ties. Okay, this is main ties. We are talking about the main ties. We have talked about the 12 mm dia bar. Okay, this is done. How to calculate? How to calculate 16 mm? This is also I have shown you. Weight also I have given you. This is the weight. This is the weight for 16 mm. 30 kg including wastage. And same 12 mm dia bar. You can use this formula. You can take out. Now we are talking about the ties. Ties of columns. Okay. Main ties. Main ties, how to calculate? This is, as we know, the column size is 300 by 300. Then 300 into 4 minus 40 into 4, because of all four side 1, 2, 3, 4 side, 4 side you have to deduct the 40 mm column concrete cover. Okay. Then plus 10d into 2. This is what? This is hooks. This is for using hooks. Hooks. We are using for hooks. Okay. So this is used for hook. 10d into 2. Now this came 300 into 4, 1200 minus 40 into 4, 160 minus 10 plus 10 into 8 into 2, right? Then what is coming? It's coming 1040 plus 160, and this is same is 1200. One tie's length is 1200 or 1.2 meter. Okay, and height is how much? This is mentioned here 3000. Then center to center distance is 100. Center to center distance is 100 for ties. For main ties and for internal ties. Right. For both center to center distance is 100. Then what will happen? It would be 30 plus 1 because of starting from 0. Starting from 0. Let's assume this is the slab and here you are starting. Then here you will give at 0 distance 1 number. Okay, at 0 distance 1 number. Then it will become 30 plus 1. Right? Then 1.2 meter into 31, it will become 37.2 running meter. Okay, and the weight, you know, dia square divided by 162, and in dia length you can put. Okay, then the total length is 37.2. Then this formula will work here also, same as this, how we have find out this. Okay, as same example you can use everywhere to find out the ties reinforcement weight. Okay, then this is the main ties. Now we are talking about the internal ties. Okay, now this is internal ties. How to find out the internal ties? This is very simple. This is column length and breadth, we knows 300 mm, right? Then 300 mm minus 80. 80 is what? 40 cover is here and 40 cover is here. Because of this ties is holding both reinforcement, this main bar and this main bar. Okay, so here is 40 number 1 and here is number 2 40. Okay, this both places 40 mm we have to deduct. This is came 80 minus 80 plus 10d into 2. Okay, because of 10d is this one is this and one is this. Okay, 10d into 2. Then what came? 300 minus 80 plus 10 into 8 into 2. What will come? 220 plus 160. It will come 380 mm. Okay, for number of ties, this is for number of ties 30 plus 1 and 380. It will become how much? This is 11,780 divided by 100,000. So that you will get 11.78 running meter into 2. Okay. Then you will get for this ties and this ties also. There here is two ties. Number one ties is this. This is one number and this is another number. Okay. So two ties. You will get into two ties. Okay. Weight same as 16 dia bar as I have spoken to you. Right. Now calculation. This is, I think, hope you will understand how to find out the weight of hooks, including hooks and internal bar and external hooks and main column bar. Easily you can find out according to this way. Once you will try, you will get easily how to find out. And this is very simple. Column concrete, volume for volume, length, breadth and height. This is already mentioned here. 300 by 300 and 3000. Then you can mention here 0.3 into 0.3 into 3 meter, because of you are going to calculate in cubic meter. Then you will get 0.027 cubic meter. This is your concrete volume for one column, which is having a 300 by 300 and height is 3000 mm, means 300 by 300 by 3 meter. Then your concrete is required 0.27 cubic meter. Okay. Now this concrete also covered. Internal ties cover. Now main ties cover. Main bar 12 mm, 16 mm. Now we are talking about the form work or shuttering. Okay. This shuttering work or form work, this is very simple. Already we have discussed earlier also in videos. This is 300 is one side, then you have to take the all four side. Okay, all four side you will take. This will be 3 3 3 3 and it will become 1.2, right? Then 1.2 meter into 3, then what you will get? 3.6 square meter. This is your shuttering work. Okay, this is shuttering is required. So hope this video will work on your daily uses activities. Please friends, like and share and subscribe for more videos. The purpose of these videos is only all those engineers who they want to learn civil engineering, they want to grow in the world of civil engineering, and this will be very much helpful for newcomers also and working at site, all engineers. Hope this will work. Thank you. Bye.